Morning everyone. I'm Martin O'Reilly. I'm Director of Research Engineering at the Alan Turing Institute, which is the UK's National Institute for Data Science and Artificial Intelligence. And there I run the Research Engineering group. And I'm going to talk sort of about three things today around sort of how we sort of work in cross-functional teams to deliver challenge-led research at the Turing. And I'm going to start with talking a bit about who we are, both the Research Engineering group, but also some associated sort of professions and teams around us. I'm going to talk about what we've learned over the last 8 years of working and supporting and collaborating across the Institute's research programs. And I'm going to talk a little bit about what's next as the Turing looks forward to its next 5 years in its strategy. I run the Central Research Engineering Group, which has we said in a sponsor talk earlier, is a sort of central team. It's about 40 people at the moment. It's a mix of research software engineers, research data scientists, and research computing engineers. But we've also got some associated kind of research infrastructure, research delivery sort of professions at the Turing, teams that are close to us and in the same wider organizational structure. We've got a large project and program management team, which helps us organize our work collectively, us, the researchers, all the different flavors of roles. We've got community managers, which is a role we've been sort of pioneering a bit in the research community that looks to sort of support all of those contributing to the research, both across the collaborations we have at the Turing and our partners, but also more broadly. We've got this sort of brand new role in the research space, we think, called the Research Application Manager. And if you sort of think about sort of agile software development, this is a bit like a product manager for research. And these folks are a bit more sort of user and use case focused out there as our sort of some of our research becomes maybe a research product, something that others could use and leverage. Who can use it? What do they need from us in order for it to work for their use case? And a good way to think about this, if as research software engineers, we make sure that software is reusable, RAMs make sure it is actually reused. And then finally, many of you will probably have this role in your own organizations. We've got a data team, data wranglers, data engineers, and their focus is on ensuring that as we take this data from its sort of sources and we bring it together with other things, we're getting to the point where this is research ready. It's something that we can rely on to sort of make robust and reliable analyses from, and that when we bring in new data and combine it or we update the data, that still holds true. And in terms of what we do, well, we do sort of three things. By far the most amount of our time, about 80%, we spend working embedded on research projects at the Turing, and these sort of take two forms. One is, but they're all about bridging with that research practice divide. So we're either helping researchers who are developing new methods in AI and machine learning and get those out and tested and evaluated in the world, or we're helping researchers adopt cutting-edge machine learning from the research frontier and bring it into their own research practice as practitioners. We also support research infrastructure. This is both at the Turing and also sort of as part of feeding into sort of how we organize this digital research infrastructure sort of nationally. And we support skills and community, again, both in the Turing's community, but also sort of part of the wider data science and AI community. And I'm going to talk about sort of 4 projects. 2 of them are kind of very research focused, but with that application kind of impact sort of target. And 2 of them are a bit sort of more infrastructure and skills. So the first one is AI for air traffic control. And this is some work we're doing with the National Air Traffic Service. And we're building a digital twin of the UK airspace. And this is a huge part of the engineering component. It's this sort of like framework for making a simulation and pulling in data about sort of weather and flights and planes and things. And then we're, alongside the researchers, developing sort of AI agents to sort of help kind of direct planes in that sort of airspace. And the goal here isn't to replace humans, it's to figure out how, machine learning can support humans in what is an so a very high workload, high stress sort of environment. And there was a little lull during the pandemic, but, air traffic is up to historic highs. And so we're looking at sort of ways that machines and humans can work together to be more than the sum of their parts. And another key part of the contribution from the engineering aspect is the evaluation framework, which is sort of how do we understand whether these models are working, not just are they good air traffic controllers, but are they working well and enhancing the humans there, and sort of how can we make that framework and that simulator sort of available to the wider community. So as with many other areas, we can take advantage of computer scientists' sort of tendency to take their algorithmic hammer and hit anything that has a competition. And another one that we're sort of working on at the moment that's kind of we'll also talk a little bit about when we look at the forward look is AI for weather prediction. So this is something we're doing with the Met Office, the UK's weather service, and we're sort of focusing on this medium-range weather forecast, which is out to about 10 days, and as well as telling us whether we can expect sun for our photo. Today, it's used in all sorts of places, you know, to kind of worry about, are there going to be flooding here? Do we need to sort of do some preparations for that, for example? And historically, this has been done with a very sort of physics model-based approach. You sort of do these big simulations, you sample from various points in sort of the UK, and then you try and use sort of a sort of physics simulation to infill and make predictions in between and to push forward in time. And this is very expensive, and sort of we do run ensembles, and the Met Office does run ensembles to kind of try and get a distribution of uncertainty, but it's not sort of real uncertainty, it's kind of just sampling, and also it's, you know, they can run maybe about 10 of these, because they need to make the weather prediction for tomorrow. And so the idea is with sort of a data-driven approach, machine learning, especially most of the models we're looking at are some of these deep neural networks of some kind. Many of them are much more sort of time efficient than the big simulation models, although we haven't yet seen sort of what happens when we scale up to the huge data sets that the Met Office has. But also some of them have the opportunity to maybe embed some of the physics kind of assumptions into the structure of the networks, and that's something that we're super fascinated at exploring. And in the long run, we'd like to see how can we do the best of both worlds, and I'll talk a bit more about that in the forward look. And critically is this real-world evaluation, and this is something that's been important to us since we started at the Turing, but increasingly so as we look forward. You know, how do we make sure that the work we're doing has an impact in the real world, and if it's not, what do we do to sort of make that true? Who do we partner with? And so the Met Office has a very well-established mechanism for sort of pulling updates to its current model through, evaluating those in real life against the future. So, you know, not just some nice test data we've got. And so we're looking to leverage that for the new models and see how well that they do compared to the thing that's predicting the weather at the moment. Now I want to move on to maybe some of the more infrastructure sort of focused or enabling sort of work we do. So one of these is our Data Safe Haven. So there was a Trusted Research Environment community sort of satellite event on Monday, and there's been a few sessions on trusted research environments during the conference, and this is our trusted research environment. It's a scalable, cloud-based one that you can reproducibly deploy. It's open source, so you could sort of deploy it tomorrow afternoon if you wanted. It targets Azure, and it sort of lets you use sort of, you know, large memory machines, as many as you want, and sort of assuming you can get a quota from Microsoft and you can afford them, the latest GPUs. But it's more than that. It's also, you can't just put the technology out. Information governance is kind of what lets you really sort of actually get sensitive data into your environment. And so we've shared what we do at the Turing. We're not saying that's what you should do, but if you used our platform and you used our governance, you should feel in a reasonably confident position. You can't absolve yourself of all responsibility of getting it right, but you know, it's a much better place to start than where we were in 2018. And one of the challenges is that nobody sort of has been sharing this sort of stuff. Everybody's been starting from scratch. And that doesn't just mean that we're all doing the same work again. It means that it's just really hard to point to kind of what normal looks like. And so when you talk to each of these data providers who feel very responsible for the data they're holding on behalf of the people who are in it, you know, they're having to make these decisions about 100 different options, and you know, rather than, oh, this is commonly accepted option B that's both safe and useful. And this is the last part. It's a really key community collaboration. And so here 2 years ago, we launched the UK TRE community, about 30 or 40 people in a sort of room down the corridor. And this year there were 200 people, half online and half in the room. In the community itself, it's over 300 people now, all working together. And we've been developing some common standards, initially high level, what is it that we're all trying to achieve? And we're looking to bring those down to, okay, here are some commonly accepted ways that are good and safe and useful to do that. And then we've got maybe something a bit more on the skills or the sort of practice side of things, the Turing Way. This has been running again for a similar amount of time since our early days. Started as a guide to reproducibility, but it's now a much broader guide to sort of good data science practices, and I think we'd stress good enough. So what is it that researchers can do day to day that will sort of really help their lives? And it's a global and collaborative community. It's by far the most popular GitHub repo we have. It's got 400 contributors and more across the world. And recently we've launched a Turing Way Practitioner Hub, which supports, provides more hands-on support for mostly small, medium enterprises, but others to sort of adopt these practices in the real world. So I'm going to talk a little bit about what we've learned, and I'm going to talk about two sort of ways of that, how we work on projects and how we collaborate, but also how we organize ourselves as one of these sort of research infrastructure teams. So in terms of the shape of our collaboration, get involved early. So certainly at the point where we can scope our contribution, and ideally at the point where we can sort of shape the project as a whole, we see a huge difference in what we can achieve together with the researchers and other shapes of roles if sort of we're doing that rather than sort of coming in with, oh, we've got a half a person for 3 months and here and 6 months there, and could you do something for us? We think you can give us the moon on a stick. For us, maybe not for everyone, we think longer is better. There's a certain ramp-up time, and there's a certain, there's a certain type of thing we can do day in and day out. We can wrap your code up and make it a nice PyPy sort of package that others can use. But if we're trying to get to the point where that is also the code base that you're developing version next of your algorithm on, that's not really something that we can achieve in a 3-month collaboration. And if we want to do something that's actually supported to be used in the real world and somebody's using it in practice and we're figuring out, does it really work? And if it really works, how do we support the practitioners in using it day to day? That just needs more time. And the other sort of side of that is bigger is better. So, for a long time, the average contribution we were making on a project was 1 full-time equivalent, and we would usually split that between 2 people at half each, because it was important to have another engineering brain, someone that you could collaborate with day to day. But researchers kind of look at their team and they go, oh, each postdoc is 60 hours a week, each PhD student 60 hours a week. I can see 2 research engineers there, so I've got 120 hours. Actually, they've got 40 hours because we don't work 60 hours a week, and each of our persons are half-time. And that's the other sort of aspect, part-time is hard. So I think, our people do love the fact that they're working on different things and they like that sort of interest, but we find that when we can embed ourselves full-time, we're able to work at the cadence of the project because most other people are full-time, and we sort of have less of this risk of expectation mismatch. In terms of ways of working, when we're on the projects, I think having a shared vision is important, and so part of that is us all understanding what we're trying to achieve as a whole, not just trying to sort of fulfill this project software brief. But I think there's another bigger flavor of that, which is this kind of one project we've got 6 people on, or is this like 4 projects in a trench coat where it's 1 project per PhD student or PDRA? And we want to avoid siloing. And if you really are working on one big problem, then that's sort of easier. But to do that, you need to bring the team together regularly. It doesn't have to be in person, but sometimes that's nice. But everyone's got to sort of come together and sort of check in and okay, are we still achieving what we're trying to achieve? Is what we're doing still the best way to do that? And in between, we need to make the work visible. And we use sort of GitHub and Kanban boards and Scrum, depending on the people we're collaborating with. And then finally, this is something we struggle with ourselves, even when left to our own devices, do fewer things than people rather than many things per person. So the other sort of bit of learning, I guess, is, the Institute only started in 2016. We were fortunate enough to be a team in 2016 when the Institute started, but we've grown from 3 to 40 in that period. It's been very much felt like being a startup in a startup, and we've had to kind of work out how to do this work together. And so I think we've got these 3 sort of principles in terms of the culture and sort of how we organize ourselves. And first of these is open collaboration, and I've talked a bit about how we collaborate with partners, and we don't have this kind of one working practice that we come in and say, this is how we work. We always sort of try and co-discover a collaborative agile sort of version of agile that works for the people that we're working with. We run a collaborative leadership model, so the leadership team is, we're 40 people, and myself and the 5 principals are the former leadership team, and we sort of meet every week. And but we also have the next level down, the leads join us once a month, and whenever we're sort of figuring out what it is that we want to do and why, we don't sort of go away and lock ourselves in a room and figure that out. We sort of have a conversation with the team, usually asynchronously on a GitHub discussion. And the goal here isn't that we all sort of vote and figure it out, it's that we sort of surface what's important to people, and that when we get to the end, everybody sort of feels, I've had a chance to say what I think, and even if the thing we decide to do isn't what I would do, I understand why we're doing it, and when we then do it, I can see that is what we're doing. And then we do work like this with the wider community on the development of the profession, and I think here it's, we're certainly finding it maturing. A lot of the challenges and the things that work for us as research engineers are also things that work for these other research infrastructure and research delivery roles. Our second one is around empowerment, so we I've always had very flexible working. You can sort of manage your own fortnight. You don't need to sort of tell us you're not going to be in sort of half a day because you're catching a flight or something. We've sort of had somewhat hybrid working from the beginning, but since the pandemic, we've been extremely like full-on hybrid. You know, there's a few restrictions around projects, but nothing sort of major there. About half the team, about 20% of the team live 100 miles away from the office. Everyone's got a kind of strong influence on project allocation. We're not just looking for the person who's got the best fit and can be most productive on day one. We're looking to also match what people are interested in and would like to learn. Everyone's got 20% non-project time. 10% is yours to do what you want for your professional development. 10% is yours to choose what to do to support one of the things we do for the Institute, one of our service areas. And that might be recruitment or something for ourselves. It might be supporting drop-in sessions for researchers or things like that. And there's a lot of freedom to self-organize, and both in terms of sort of how we share knowledge amongst ourselves and at the organization. So, you know, I learned a lot about large language models for my talk by going to a sort of large language models from scratch session that the team had been organizing. We've got a weekly tech talk on Tuesday lunchtimes that's open to the wider community, and there's a bunch of other things that the team organizes. And we sort of try to not tie sort of leadership and ownership to the hierarchy, and many of these service areas, for example, are owned by sort of people at lower levels in the team. And the Turing's podcast, which is an institute level thing, is something that someone did when they were a junior in our team. The final thing is sort of learning and growth. So we've got a wide range of backgrounds, and we really sort of value that. We sort of learn from each other, and I've talked about some of the ways we do that, sort of structured, but also we do unstructured. We have an away day and a hack week each year, which is when we all come together as a team. In the away days, we tend to focus on how we work and, you know, sort of what it is, how we operate. And in the hack weeks, we focus on scratching our professional development itches and working with people we wouldn't otherwise work with. And we provide support for the team to go to training, conferences, workshops, and so on. And we have a structured and supported career pathway. So we have roles from junior to director, permanent roles from standard, junior to training role, focus on internal development. And we have promotion when ready from junior to standard and standard to senior. So there's no cap on how many people we can have at those levels. We've had 30 internal promotions to date. Hopefully that number will go up soon. We're in the middle of a promotion round. And we have regular salary progression within the role. And if you sort of go and check out our talk from 2022, you should be able to see what that salary progression looks like, you know, how the bands have gone up. But you can also expect to go through the band as you sort of work. So what's next for us? We're sort of focusing ourselves around these idea of grand challenges at the Turing. So these are societally important problems that focus on real-world impact, that can't be solved by one organization alone, that need significant advances in the state of the art to deliver. And we're looking at sort of, and we'd call each one of these a mission, and we've got sort of 3 grand challenge areas, and then a sort of cross-cutting, enabling kind of activity. So the first is environmental sustainability. And I've talked a little bit about weather forecasting, which is a mission we've sort of already started with the Met Office. We're also doing sea ice modeling with the British Antarctic Survey. We're sort of modeling renewables generation, so it's doing some nowcasting for that to help sort of plan sort of energy usage. And we're doing some nuclear fusion. That's a collaboration we're sort of just sort of getting set up, but trying to kind of help use machine learning to sort of like understand how we can model those sorts of reactions and control. Our second grand challenge area is around the transformation of health, and that's got 3 main strands, looking at how can we build a multimodal foundation model for health that sort of incorporates electronic health records and all sorts of sort of data like that. But obviously have that additional challenge of these being very, very sensitive sort of data sets. And there's kind of 2 challenges. There's how do we support clinical decision making, and that's got 2 strands. How do we evaluate these models in a clinical context, and how, a bit like the air traffic controllers, how do we get to the point where clinicians feel that they've got a tool that helps them make better decisions and faster decisions, and that they can be confident in. And the third strand is there's a lot of underpinning technology for this. So we talked about trusted research environments, and that's a huge part of it. How do we get sensitive data, or maybe slightly less sensitive data that's more accessible, so that we can genuinely develop these sort of methodologies and algorithms against realistic data? But also, how do we make that pathway back to production sort of work? How can we take something that's developed over here, maybe with less sensitive versions of the data, run it against the real data so that we can really understand, does it work? Then run it in a clinical sort of context so we understand, okay, does it work in the hospital? And then when we're running it, how do we take the learning from that back to the development of the algorithms? Our third area is defense and national security, and here we're focused on models of sort of understanding critical national infrastructure and how it can be defended, and on sort of can we automate sort of that sort of cyber defense activity. And as well as sort of developing these models, and a bit like the air traffic control, having a framework where we can sort of understand how these models work and develop and test them, how do we have an evaluation framework that sort of makes that accessible to a much wider community and leverages sort of all the things that people are doing in different places. The last thing is fundamental research. So there we've got three areas around probabilistic and generative modeling for physical systems, bridging the data-driven and mechanistic models. So we talked about that with our sort of Met Office work already, and machine learning for accelerating large-scale simulations, which is some of what we hope to do with the Fusion work. And so sort of what's different? Well, it's a North Star mission focus, long-term cross-functional teams to deliver, integrating research applications. And if we sort of think with our software engineering hats, this feels to me like the transition that was made in industry from a project focus to a product focus. Put a long-term team together, common goal, and then you make all of that stable, and then you can be sort of agile and flexible about what you prioritize next. And what's different for our team? Well, we've pushed off, we're 40 people, we've needed substructure for some time. We're going to align it to the challenge areas. We're going to have longer full-time allocations, and we talked about why that might be good earlier. And that will allow us to build deeper expertise, which is a common challenge the team has. I just learned this thing, and I haven't got the chance to become an expert in it. I'm feeling like a jack of all trades. But hopefully, we don't have to trade off that ability to try new things and flex the shape of our role, do a bit more research, a bit more infrastructure, a bit more software. And this is how you can come and be a part of that. We're not quite recruiting, a little bit like Newcastle, but we're hoping to soon. So on the top right there, please join our mailing list to be notified when we're recruiting. We do have some roles at the Turing on these sort of the first missions coming up under our grand challenges, PhD studentships, sort of different levels of research associate and some mission leadership roles, and they'll broadly be aligned to the same sort of salary bands as you saw earlier. So please follow that link to our jobs and apply. I think they close on the 10th of September. And one of the things I didn't mention is that we sort of host a lot of placements, including from other RSE organizations, and one we're working with at the moment is Sheffield, and they are hiring at the moment, and that person will spend half their time working with our team embedded at the Turing. So thank you very much.
Thank you very much, Martin. We already have some questions on Canopy. So the first question is from Anonymous.
Okay. It's a very popular question asker, this
I know, they're asking so many questions. They're such a prolific asker. But yeah, they have asked, how do we balance the benefits you mentioned of having multiple full-time RSEs working for a long time on a project versus the alternative benefits to LE, which does not show the full comment on my phone?
Yes, is there a net benefit from focusing? Yes, no, this is a really useful question, and it's something that certainly our team value, but we've also hired specifically for people who are interested, able and willing to work on lots of different things. And it's a bit of angst that we have because we know what the past looks like and we enjoy it, but we don't know what the future looks like yet, apart from this Met Office work, which has already started. So I think my answer to that to you would be the same as to the team. These are sort of bigger things. They've got these huge kind of high-level goals, and we don't know how we're going to get there. And one of the challenges we have when we're short-term on a project is, how much are we allowed to get into the research? So one of the things people want to do is learn more about the research and read more into the papers and sort of be part of that side of things. Or maybe they want to pick up a new skill on the project, but they're getting pressured to kind of deliver, with the stuff that we promised. And I think when you're in these larger teams, the two things are true. You've got more time and space to do that. But also, I think all of the roles sort of blend a bit more. The researchers will end up cutting code, and they'll end up doing their research code in the same sort of repository as the code we're releasing for others to use, and therefore there'll just be a lot more ability for people to, I think, flex their roles, whatever your initial role is. So that's the vision I would sort of sell you on that. I don't think it's necessarily a trade-off, but I think it's difficult to do if you don't have these very large long-term teams and this stability, and that is not necessarily the norm.
Thank you. So the next question that's come in is from Ghislaine Vaillant, who asks, could you give us some details about how agility works in practice in this environment?
Right, yes. So I flip backwards and forwards between thinking we are totally winging it on agile practices and that we're sort of super mature on agile practices. So I think if you step away from naming things and sort of recipes, agile is about, at its core, self-organizing teams who sort of work out what works for them. And it's a way for us to make some things stable and certain so that we can sort of be flexible about other things. And you know, whether it's Scrum or whether it's picking one thing at a time, you know, from Kanban, I think the fundamental thing we do is we say, we're going to make all of these things unchangeable, at least for a time, so that we can just be really flexible about what we do next. And that we also, as we do it, we sort of make sure that that work is usable. It's not something that we're going to need, you know, weeks and weeks and months of additional work to make work in practice. And I think what we found is how we do that work, both on the technical side of the practices that we might use for getting two eyes on something or for getting quality control in, but also on how we collaborate on choosing what to do next and how flexible we are on that, for us is something that we sort of have to work out with every set of collaborators that we do. So it might be that as we have these big stable teams all working together at the Turing, we sort of distill out a common set of practices. And if you are, Carlos in our team is giving a talk on some of our experiences of Agile at the Turing, sort of in 1 or 2 talks time, so please do sort of jump in on that and you sort of learn a bit more about sort of where our current thinking is. But yeah, I think we don't have a single way of doing it, but we sort of do work this out with every set of collaborators. And again, this is something we'll do with these new teams as we join them.
Thank you. So we have at least time for one more question. So Andrew Lister asks, does the 20% non-project time allow for general open source contribution?
Yes, and we also have an open source service area, which we have. So some of our service areas we also fund out of the Turing's core, so we treat as part of our infrastructure commitment to the Turing. And at various points in time, we have had people sort of spending their time on that. So one example is Sarah Gibson, who now works at 2ITC, is at the conference here. I'd encourage you to talk to her. They're a great organization. So she's now an open source infrastructure engineer, but she joined us as a research data scientist and then sort of decided she was a research software engineer, and that was a sort of great journey we were happy to support. But she got an SSI fellowship. Again, you should apply for one of those if they're interesting. And what we did was we said, well, you're going to get this funds from the SSI fellowship that lets you do sort of conferences and run events. We will sort of double your time. You can spend your 10% time, but we'll give you another 10% that we'll pay for. We did that during the fellowship, and the thing she did was do some open source contributions to Binder and Binder Hub, and we stood up an instance. So for a while, we were one of the 3 sort of nodes you would be running on if you deployed something on the public Binder Hub. And after Sarah's fellowship finished, we sort of maintained that support as a service area. And we still run an open source service area. And I think the amount of buyout we put in sort of depends on the enthusiasm and the concreteness of the contributions people want to make. But aside from that, we also encourage people to do that as part of their work. And we say this, you know, easier said than done. You know, we're there in the projects. It's very, very easy for us to kind of lean in and help the researchers get an additional paper versus, oh no, what we should do is wrap this up and get it up there. But on multiple occasions, we have gone, look, rather than release a package of our own, let's take this method and let's push it upstream to a package that already exists. So those are the various ways that we sort of support that. So I think the question was yes, no, and the answer is yes. And there was a bit more information there.
Thank you very much. That is all the time we have for questions, but if you want to talk to Martin, I'm sure he will be around. The Turing has a sponsor stand, so you can go and find him there. So yeah, there's plenty of questions, but if you didn't get it answered, go find him. But yeah, let's thank Martin again.
Cool.